favorite chapters in mathematics apart from this. And uh, chapters of them is first this. Now, I will break down it. We will say functions of a circle, parts of a circle. Okay, let's start from figure. From figure. You know that this is not a perfect a circle, but let's assume that this is a perfect circle. Now, this curve, which is this curved line, it is line, but curved line. It is line, but curved line. Okay. Now it is closed. There is this curved line is not open, so it is a closed. We say that it is a polygon. Yeah, it is a polygon. Now our topic is this closed curved line is circumference. 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 Okay. Oh, this. I'm not talking about area, this area. No, I'm not talking about this area. I'm talking about this closed curved line. Okay. Is a circumference of this circle. Now, next is a point. Now, this circle is made up of a lot of points. A lot of points. There will appear point like that. There are a lot of points on circumference which is made up, which is used to make a circle. Okay. Now we are taking a point which will be located at the middle of the circle. It will be known as origin. Otherwise, you can say center, origin, center. What else? So this point is origin. This point is origin. Otherwise, you can say center. Now, from here, we are applying a line segment from here to this circumference. So, a line segment which is starting from the center to this circumference will be considered as radius. Will be considered as radius. This was origin. Okay. So definition of a radius of the circle will be what a line segment which is being started from the center of the circle to the circumference of the circle is a radius. Clear? Now what about diameter? What about diameter? Look, diameter is just two times of radius. So radius, there are two radius together in a straight line will be diameter. So from here we are observing that two radius in straight line is a diameter. If diameter is half, then half diameter will be radius. So let's say this is radius. Okay, radius can be a lot of radius are a lot of inside the circle. This is also radius from here to till here is also radius. Now I am making a line segment which is a diameter, which is a diameter. Okay, I am naming each line segments so that we can identify which line segment is, what is the name of this line segment, what is the name of this line segment. I will arrive later. So here, from B to C, from B to C, definition of a diameter. Let's understand a point. Otherwise, we can say line segment. A line segment which is starting from this circumference is going passing the center of this circle to the next circumference, to the next point which is on circumference. So line segment is starting from here and it is passing through the center, then it is going to the next point which is on circumference. So this line will be considered as diameter. Okay, diameter. diameter. Okay. So diameter is just two radius, one radius and two radius. So half diameter is a radius, two radius is a diameter. If a two radius is in straight. Now what else? What else? From here we understood this. Now next. Now next. This is chord. This is chord. So here in this ALM is a chord. ALM is chord. So definition of a chord is if a point there is a line segment which is not passing from a circumference is not going through passing what center of the circle. If a chord line segment, if a line segment, otherwise you can say if a line segment which is not passing through center of the circle will be considered as a chord. If a line segment is going from a point to passing center to the next point will be diameter. But if a line segment is not passing a center, then that line segment will be known as a chord. Okay. What else? What else? So highest chord will be what? Half circle will be diameter. So highest chord will be diameter. You know. From here, you will observe one thing. Chord. This area. This area is what? Segment. This area is segment. We are talking about area here. Segment. Okay. Now this line is a chord. This line is a chord. But this area is a segment. And here this is also area. This is also area. So it is what? Nothing but also segment. So what's the difference between this and this? You can name both this by saying this is minor. Of course, this is less than area of this segment is less than area of this segment. So if this is less, then we can say this is a minor segment. If this is a more, then we can say this is major. This is major segment. Clear? Now segment is made of, if there is a chord, that chord will make a segment. Chord will make a segment. Why am I saying like that? Because we will see in the case of a sector of the circle. Would you like to see here? 1 second. This is a circle. Now sector will be created by two radius. This is, and two radius will be not in straight like that. Two radius will be like that. Okay. Now sector will be formed by two radius. This sector is area. Segment is also area. So this area we can say we have angles. So this area will be known as sector. And here this side you can say this is also area. And this area is covering by two radius. So this is also sector. This is also sector. But no, there are two same sectors. So we can say this area of this is less, then it will be minor. If area of this is more, yes, you can say definitely this area of this is more. That's why we are naming it by saying a measure area. Clear? Measure area. You can see. What's the difference between segment and segment and sector? Sector will be formed by taking two radius, whereas there will not be radius in the case of a segment. There will not be radius in the case of a segment. If a segment is highest, so highest the segment will be considered as diameter. Okay, diameter. What else? Now you can see here there is a diameter in the circle will be there two parts. There two parts half circle, two parts which will be half half. Okay, this half. Clear? Now to find the circumference of the circle, you will have to use formula. You will have to use formula to find the circumference. Or even we know that to find a total distance of a boundary of any shape, we just add up with them, add up a distance. So there is a formula so that you cannot take a long time. Okay, without wasting time, you can apply formula so that you can save time. Uh, to find a circumference, 2 pi r, 2 pi r. Now we can say, is this formula correct or not? It is saying 2 pi. So here, from here to till here, we know there is a 1 pi. From here, from here to till here, there is a 1 pi, but not exact 1 pi. There will be something space after 1 pi. Now we are saying from here to till here, there is 1 pi. So same here, there will appear second pi, but some distance will be gap. So that's why it is named pi. Okay, pi. Okay, where number is not exact. Number 3.17 will be approximately equal to. So here 2 pi and 2 radius. Of course, diameter, there are two radius. There are two radius. Okay, there are two radius. So 2 pi r is a formula to find the circumference of the circle. What else? Area. 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 Whole area I'm talking about. I'm not talking about area of a minor sector of the circle, area of a major sector of the circle. I'm not talking about this right now. I'm talking about full area of the circle. Full area of the circle will be what? Pi r square. Even you can say we take a common. Here after finding formula we apply a square which shows that yeah there are two times. For example, 5 centimeter square. So 5 is a 2 times 5 multiple 5. That's why in formula we take a common. So here pi is a 2 times, r is a 2 times. Okay. Similar here you can say 2 times. So here this is a 2 multiple 22 by 7, but this is not a 2 multiple 22 by 7. It is what 22 by 7 multiple 22 by 7. Okay, r multiple r like that. So this is a formula to find the area of any circle, IR as well. Just apply this formula. If the question is the same, find the area of the circle. Then okay. What else do we need to do now? What else? Just have a look. One point more. One point more. I want to tell you about the circle. Here look, this is a circle. Now we are talking about arc. Arc is nothing but a part. Arc is a part of a circumference. Arc is a part of circumference. For example, from here to till here is what? Arc. So this part of the circumference is arc. So now from here to till here is arc. AB is arc, which is a part of the circumference of the circle. So what about this? This is also arc, which is a part of the circumference. This so we can say this is also arc. But what's the difference between this arc? How to know that we are talking about this arc? When to know that we are talking about this arc? What you can name? You can name each about this arc by saying this is minor. This distance of this circumference, which is a part, is what? Less, and distance of this arc is a more. That's why this will be more. This will be more. Clear? This is less, minor. This is more, major. Now let's take some questions based on this, so that we can practice. We can have clarity. First question is simple. The longest it is the same. The longest chord. We know that longest chord is what? This longest chord. Longest chord will pass center is a diameter. Diameter. Okay. So longest chord is a diameter. Longest chord of the circle is the diameter of the circle. Clear? Now next question. Next, an arc read this question and answer me. It is saying an arc. There is an arc. Is a when its end this there are two ends are ends of a diameter. So this arc is going from here. This is arc. It is talking about this arc. This statement is talking about this arc. Now, this arc is saying an arc is what? This is a semi arc. Semi arc. What else? Semi arc. Otherwise, we can say segment. But semi segment. So semi arc. Otherwise, we can say semicircle. Because there is a being taken diameter. That's why semicircle. So semicircle. Next question. Next is a segment Now read this question. Question is saying segment of the circle. Segment. Segment we know that segment is made up of a chord or a arc. Segment. We know that segment is area. Segment of a circle is the region between an arc and chord of the circle. Chord. Okay, we know segment is a made up. Segment is a region which is made up of arc and chord. So there is arc, chord. There is also a chord. Is that correct? You can see. Now next question. Read it carefully. A circle which divides the plane. This is a plane. Circle is a dividing. So on which it lies in. On which it lies in. One point more I would like to discuss about circle is that inside this area is known as interior part. This outside part is known as exterior part. And on the circumference will be what? On the circumference. Okay. On the circumference. So here we have three parts. This is one, this is second, and this is third. So three parts. A plane which divides in three parts. This is first, this is second, which is outside area, this is inside area of the circle, this is outside area of the circle, and this is on the boundary of the circle. Now, there is a statement, and you have to tell that statement is correct or not. If correct, then tell why. You have to give reason. If not, then again also you will have to give reason. What is it saying? It is saying a line segment joining the center. A line segment joining the center to any point on the circle is the radius of the circle. So no, line segment. It is talking about a line segment. So radius is not line segment. Radius is not line segment. So it is saying that there is a circle. Let's say there is a circle. A line which is starting from the center, goes to the circumference of the circle. So it starts line segment starts like that. It is talking about segment like that. There are a lot of radius. There are infinity radius. So it is talking about line segment joining this center to any point of this circle. On this circle is a radius. Yes, it is a true. This is true. So line segment is starting from this center. Now next, a circle has only finite finite number. Now you tell me, is this a given statement correct or not? A circle has only finite number of equal chords. It is saying there is what finite which means limited, but there are a lot of even we cannot imagine, and we don't know what is the radius. Radius can be any number. So radius are different of the circle. So of course chord will be infinity, even infinity. So this statement is talking about this chord. So there are a lot of finite number of equal chords. So there are not a finite number of chord in a circle, in any circle. Rather, there are a lot of there are infinity number of chords. So this is wrong because of finity. False. Now next. Read it carefully. You will get a idea. If a circle which is divided into three equal arcs. Let's say one is one and the second one is one, second and third. One, two, third. Equal arcs. Each is measured. So each is not a measure arc. Okay. Arc three. There's a three arc are equal to each other, not a measure. Okay, this is wrong. Now next. Now this is a statement. A code is this statement saying there is a code. A code of a circle which is twice as long as its radius. Its radius. Here I got it. It is saying that let's say this is a code. Okay, this is a code. Now this code is a twice of radius. There is a two radius. Now you can say there is not a two radius. There is a not a two radius. Let's say this is a radius. Distance, there are two radius. Okay, distance of this two radius, and this is a chord. So distance of this is more than distance of this. That's why we can't say that this is two radius. This chord is a two radius. Is the diameter of the circle. Is the diameter. Now sentence. Next sentence is saying there are two radius which is there is a diameter, okay, which are made of two radius is making a diameter of the circle. Yeah, it's a true. But when it comes to here, this when it comes to this code, then in this case this statement will be incorrect. But it is talking about a diameter. It is saying there is a diameter of the circle, but a diameter is making by taking two radius. So it is a true. I would say it is true, and I have given reason. Now, next part, next topic. Look, we have a circle. We have a circle. Now we are taking a sector, minor sector, minor sector. Okay. Here you can see. I will draw a major circle so that we can have a clear clarity. Now there is a center. There is a center. Okay. Try to understand carefully because from here you will get a concept. Okay. Something will be different. So we are making a sector. This area. Sector is a region. Sector is a area. So this is a minor sector. You already know. We are drawing a chord land segment. This is a chord land segment O A B. Now, main point is what? Here you will see three angles. Three angles. So first here you are notice that this is one, and second here you would see like that. Okay, like that. There is also one circle. Second, this is the angle. This is the first angle. This is the second angle, and from here you can see even like that. You will see. So we can make three angles. First, this angle is making inside major segment, major sector, major sector. But this angle is making inside the minor sector, and this angle is making inside the minor segment. So there are three angles which are separated. Okay, it is saying that measure of this degree is, let's say, 55. Then measure of this degree would be how much? two two times or more. So this is like that. Okay. So measure of this is 55. Now, if this is a 55, let's say this is a 100. Okay, this is a 100. So it will make a how much? 50. You can see. So it will be half of this degree. Okay, this is a theorem you can see. So this angle is making 100 degree. So this will make half of this degree. Clear? And this was a concept from this circle. Now I am going to take theorems. Okay, this is a theorem. Theorem is a statement which is universal truth. I am drawing a circle. In this circle we have two sectors. We have two triangles. We have two triangles. One is OAB and second is OCD. OAB. This is one, and second is a triangle OCD. Now it is also saying that you can read this statement: equal chords. This is a chord. Already we know. This is a chord. We have understood meaning of a chord. This is a chord. This is also chord. But you can't say that this is a chord. This is a radius. This is 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 a diameter. This is a diameter. Okay. Now statement is saying equal chords of a circle subtended equal angles separated separate equal angles at the center here. So this is angle 1, this is angle second, this is angle 1 of for this triangle, this is a second angle for this triangle. What's the difference? Now this we I am saying that angle of this is let's say 60 and angle of this is 60. So both angles is 60 because of reason is chord. Measure of this chord is let's say 5 and 5. Okay, and measure of this chord is also 5. That's why both angles of the both the triangle will be same. This is a theorem, which is a statement, which is a statement is universal truth. Now here you can see if measure of two chords of two triangle is the same, then both angles will be same. Reason is equal chord. Clear? You can say here. This is a hint which is telling us that measure of this chord is equal and measure of this chord is equal. Now I am going to take second theorem. Second theorem. Now, this theorem is there is a twist. Twist is that it is saying just in the previous question, in the previous theorem, we understood whatever. So same here you will realize how if the angles subtended by the chords of a circle at the center are equal. If angles are equal of a circle by the chords, then of course the chords measure of chords will be equal. For example, this is okay. So here angles. So we have two chords. Let's say two chords. So at the center. So chord is like that. Chord is like that. Point is what from center. This angle will make when we will draw two radius. When we will draw two radius, then we will see angle. Now it is saying if the angles are separated, there are two angles. Okay, by the chords of the circle. Then at the center, angles at the center will be equally. So then the chords are equal. So it is saying if this is 60, this is let's say 45, 45. This is 45. This sentence is this. Okay. Now this sentence is saying if angles of both triangles is equally, then measure of chord will be equal. Let's say 6, and this is also 6. Okay. This was just opposite of the previous theorem. Now next is what? Next is This is what a circle. Okay, we are talking about now perpendicular line. There is a chord. There is a chord, and perpendicular will come. We are drawing a perpendicular from the center. It hits the surface of the. It hits. It strikes the chord. The chord. This is A. This is B. This is O. Now here you clearly can see that this is angle. This is making angle, which is straight. This angle is 90 degree. You know that perpendicular is exact is like right angle. Perpendicular is exact right angle. So yeah, like that perpendicular will appear like that. Okay, you can see perpendicular. This is perpendicular. So here you can see OL is a perpendicular to AB line. Okay, so OLB is equal OLA is equal to 90. Clear? This was what we had to study. Now, one theorem. From this, there is a one theorem. You will get idea. No. Theorem is saying bisects the chord. This is a statement. Now, from this statement, we can have clarity. Let's draw a figure of a circle. Now, the perpendicular from this center, a perpendicular is coming from this center. Okay, from this center of a circle to the chord, there is a chord. Let's say this is a chord, and this perpendicular is coming from the center to the chord of the surface of the chord. This is A and this is B, this is O. Bisects, when it comes to bisect, it means that there will be two parts of a something. For example, this is line segment, and question is saying there is a bisect. There is a bisect in this line segment. So bisect, which means this part, both. So measure of this, let's say measure of this was 8 centimeter. Now from here to till here, measure of this will be 4 centimeter. From here to till here, measure will be 4 centimeter. Equally, main point is equally. When it comes to bisect, then now here we are talking about this perpendicular from the center of the circle to the chord bisect equally. Bisect the chord equally. So of course, so measure from here to till here. Let's say measure of this chord is how much? Again 10 centimeter. So this will be 5 centimeter, this will be 5 centimeter. And you know that this is 90 degree, this is 90 degree. So here bisect. Suppose, so it is saying that AB is 10 centimeter, then AM will be 5 after bisecting. After bisecting the chord, the chord AB will become 5 centimeter and MB will become 5 centimeter. This is the meaning of bisecting. Okay. It is also it comes also in the lecture of line angles. These are concepts, theorems are concepts. Now next, this was third theorem. Now next is fourth theorem. Fourth theorem. Okay. Again, this I think so. This will be opposite just of theorem 3. Now this is the third theorem. Just read it, then see what is happening. What is happening? We have to understand the statement which is a theorem, and theorem is a universal proof, universal truth. The line drawn through the center, it is talking about circle. Can we draw a circle? Of course. So a line which is drawn through a center, okay, uh, of the circle to bisect a chord. So a line is bisecting, a line is drawing through the center to bisect the chord, to bisect the chord. Now this is bisecting is a perpendicular to the chord. Chord is AB. Let's say Amen. So this line which is coming from the center is bisecting the chord. Chord is Amen. So here it is making what perpendicular. Yes, we have now. So of course this is a making perpendicular. Perpendicular is what perpendicular which makes at 90 degree. Okay, this was. So here OP is what? Is a bisecting the chord, bisecting the chord. Where angle OPA is what 90 degree now. So angle OPN. Now here main point was what OP is perpendicular to AMN. This was main point from here, from here. Okay. Yes, OP is perpendicular to AMN. When it comes to perpendicular, then uh, perpendicular will make a 90 degree angle. It is the universal truth that perpendicular will make 90 degree angle. Just have a look. This was the theorem 4. Now next theorem. Next is 5. 5 is very interesting. You will enjoy. Just stay a few minutes. Theorem number 5. There is a twist. Twist is that do you know meaning of a collinear? Do you know meaning of a collinear? Now, collinear, which means when it comes to points, then there is no point which is line segment. No, here point is a point of a circle. If a points are collinear, which means points will be in straight, 3 points, 4 points, more than 2 points are collinear. If 3 points are in straight, will be collinear. If three points are not in state, will be non-collinear points. Okay, and this statement is saying there is one and only one circle passing through three given non-collinear. For example, let's start from one. This is one. So can a circle, how much circle can can pass this point? How much? This one, this one, again this one, this one, this one. So each circle is passing through this one point. So we can say from here that there can be a lot of circles which can pass a single point, but point is collinear. Point is collinear. When it comes to collinear, for example, we are taking uh, one one point we have seen now 2 points. This is one. First, let's start. 2 points are collinear. 2 points are collinear. 2 points are a state. That's why this is collinear. Now this is one. This is one. Okay. What else? Nothing but only one. Only one. Only one. There is only one circle which is passing 2 points will be one circle. Now collinear. Let's come to the topic. Here collinear, non-collinear. If this is one. Collinear. Okay. This is one and this is one. Let's pass a circle through this given non-collinear. This like that. This is a crossing. This is crossing. This is crossing. This is crossing. This happened. This happened because of non-collinear bonds. What if there are three collinear bonds? This is not a non-collinear. This is collinear. You know. Now you have to draw. You have to draw a circle which will be passing collinear points. All collinear points. Now let's start. This is passing. This is passing. Only two points. This circle is passing only 2 points. What about one? What about left 1 point? No. Even you can see this will make like that. So what about this point? That's why we can say a only one circle cannot pass three given collinear points. But there are non-collinear points, then one single can be drawn, which will be passing the given non-collinear points. Okay, this is universal truth. Theorem is a statement, is a universal truth. So this was that we understood. What about what else? Theorem number 6. Theorem number 6. this is statement. It is saying equal chords of a circle. There is a one circle, okay. Equal chords are equidistant from the center. Again, same. So there is a equal. This is equal. Okay, this is equal. Clear? Now, equal chords of a circle is coming from 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 center. Okay, so this is equal. This is equal, and this is what this statement is saying. Okay, so measure of chords is equal. So equal chords of a are equidistant. So here this was. So here this is a point, and now a line segment is coming from the center like that. Okay, this is making perpendicular. Now this a distance. This is not a radius. This is not radius. Equal chord of a circle. There are two equal. So are equidistance from the center. So this is making 3. So this will be make also 3 from the center. Clear? This is equal. Now next we have to prove. This is question and figure will be different from the previous. Now you can see figure. Figure is like that. Now we are going to prove it. Given Here center is between. Now what is the meaning of concentric? Concentric, centric, center, center. Okay, center. Concentric, which means center will be one, but radius will be two or more from a single center. This is one center which is for this center, for this circle. This is also radius for this circle. This is what is the meaning of a concentric circle. Okay, there are two circles, but center is only one. One center is for both the circle. If a line intersect, now here, a line is intersecting two concentric circles. Yes, you can see this line is intersecting the two given circles with the same center. So this is the meaning. This is the meaning of a concentric circle. Two circles. These are two circles. There are two circles with a center. With center O at A B C D. So here A B C D is a view of intersecting. We have to prove that AB is equal to, so here this distance is equal to this distance. Clear? Now this is O. Here a line can be drawn which is making at 90 degree, is also known as a perpendicular. Okay, is also known as a perpendicular. Okay. Now what is here? Here given is we have constructed O is the center, OL is perpendicular to AD. Yeah, we know. This is not given. So here OL is perpendicular to OAD, whereas OL is also perpendicular to BC. But we start from one perpendicular. So from OA AD. Okay. Here you can say what can you say? OL AD. So here OL is a bisecting. OL is a bisecting. Meaning of this is what? OL is a bisecting AD, which means a distance from AL from A to L is something will be same here, L to D. So here we can say AL is equal to ALD. Reason is bisecting. So from, you can say this is one. From second perpendicular BC. Now meaning of this is what? OL is bisecting the BC chord. Now from your BL is let's say 4, then LC will be 4, same. So BL and LC. So this is the second equation. From 2 minus 1. Okay, minus 1. Now this is 2 BL minus AL, LC minus LD. Okay, here you can say BL minus AL, BL minus AL. When we will BL will go on from AL, will left what? AB. Here LC is where? This is LC. This part is LC, and from here to till here is what? ALD. Okay, ALD. So this part will go on. Then this part will be left. So CD is left. Clear? We have done what? We have subtracted. LC will go on from LD. CD will be left. Same here. BL will go on. BL will go from AL, then AB will be left. So finally we have proved this, proved AB. This is what we had to prove, and we have proved. You can see. Next theorem is very interesting, and we have same. But again, by the theorem, I want to discuss this theorem with you, even if we have seen. But from perspective of a theorem, I want to explain this with you. Next theorem is number 8. This is theorem. I read it. Now this is saying the angle subtended by an arc. This is a circle. Angle is being subtended by an arc at the center is a double. This is, so this is arc will be, there will be one arc. So here is a double by an arc at the center is a double. If this is a 45, if this is a 66, then by it at any point on the remaining part. So here this will make how much? Half. So this remaining part of the circle, this remaining part of this circle is what? Making angle, which will be half of this 33 degree. This is what? This is the same. Clear? If degree is given of this angle, we can easily find degree of this angle. Okay. So truth is that if angle of this is 100, 200, let's say 200, then this is a truth that angle of this remaining, which is coming in a major sector, will be what? Half. This is universal truth. That's why we take theorem. Theorem tells us a truthful story, truthful concept. So what is the truth? This is making something 106. So of course this will make 58. Half. Okay, half. Next. That's all. We will. I will discuss whatever we didn't discuss in this lecture. I will discuss in upcoming lecture.